When panel B is fed through the lugs of panel A, the load from panel B must be included in the load calculation for panel A. Think of panel A as the main distribution point for both panels. Therefore, its capacity must accommodate the combined load of both panel A and panel B. To understand this better, let's delve into the reasons and implications. Firstly, panel A acts as the source for panel B. This means all the current drawn by panel B passes through panel A's main breaker and busbars. If you don't account for panel B's load when sizing panel A's components, you risk overloading them. Secondly, an overload condition can have serious consequences. It can cause the main breaker in panel A to trip, interrupting power to both panels. It can also overheat the conductors and other components in panel A, potentially leading to damage or even a fire. Thirdly, National Electrical Code, NEC, Article 220 provides guidelines for calculating electrical loads. These calculations are essential to ensure the electrical system is safe and performs as intended. When dealing with subpoles like panel B fed through panel A, it's crucial to follow the NEC guidelines to accurately determine the total load on panel A. Now, let's consider the steps involved in calculating the load on panel A when it feeds panel B. 1. Determine the total connected load of panel A. This involves adding up the amperage of all the branch circuits connected to panel A. 2. Determine the total connected load of panel B. This involves adding up the amperage of all the branch circuits connected to panel B. 3. Apply any applicable demand factors to the loads of panel A and panel B. Demand factors are used to account for the fact that not all loads will be operating at their maximum at the same time. NEC Article 220 provides demand factors for various types of loads. 4. Add the demand-adjusted loads of panel A and panel B together. This gives you the total load on panel A. 5. Select a main breaker for panel A that is rated to handle the total load. The breaker should be sized at 125% of the continuous load plus 100% of the non-continuous load. 6. Ensure that the busbars in panel A are also rated to handle the total load. The busbars are the metal strips inside the panel that distribute power to the branch circuits. To illustrate this with an example, let's say panel A has a connected load of 100 amps and panel B has a connected load of 50 amps. After applying demand factors, the adjusted load for panel A is 80 amps and the adjusted load for panel B is 40 amps. The total load on panel A is therefore 80 amps plus 40 amps, which equals 120 amps. In this case, you would need to select a main breaker for panel A that is rated for at least 120 amps. You would also need to ensure that the busbars in panel A are rated for at least 120 amps. It's also crucial to consider future expansion. If you anticipate adding more loads to either panel A or panel B in the future, you should factor that into your load calculations. It's always better to oversize the main breaker and busbars slightly to accommodate future growth. Let's elaborate on the concept of demand factors. Demand factors recognize that electrical loads don't typically operate at their maximum capacity simultaneously. For example, in a residential setting, you might have a refrigerator, a washing machine, and a television all connected to the electrical system. However, it's unlikely that all three appliances will be drawing their maximum power at the same time. The refrigerator cycles on and off, the washing machine only runs for a portion of the day, and the television might not be on all the time. Demand factors allow you to reduce the calculated load based on the likelihood of simultaneous operation. The NEC provides tables of demand factors for various types of loads such as lighting, appliances, and motors. These tables are based on statistical data and experience. For example, the NEC might specify a demand factor of 0.75 for general lighting in a dwelling unit. This means that you can multiply the total connected lighting load by 0.75 to arrive at the demand-adjusted load. Using demand factors can significantly reduce the size of the main breaker and service entrance conductors required for an electrical installation, saving money and reducing the risk of oversizing. However, it's important to apply demand factors carefully and only when appropriate. If you're unsure whether a demand factor applies, it's always best to err on the side of caution and use the full connected load. Now let's talk about the importance of proper wiring and connections. When feeding panel B through the lugs of panel A, it's essential to use appropriately sized conductors for the feeder wires. The feeder wires are the wires that connect panel A to panel B. The size of the feeder wires must be adequate to carry the total load of panel B, plus any additional load on panel A. The NEC provides tables that specify the ampacity of different sizes of conductors. Ampacity is the maximum amount of current that a conductor can safely carry. When selecting feeder wires, you must consider the ampacity of the conductors, as well as the ambient temperature and the type of insulation. It's also important to make sure that all connections are tight and secure. Loose connections can cause overheating and arcing, which can lead to fires. All connections should be made using approved connectors and terminals. Furthermore, it's crucial to properly ground both panel A and panel B. Grounding provides a path for fault current to flow back to the source, tripping the breaker and preventing an electrical shock. The grounding system must be installed in accordance with the NEC. Typically, a grounding electrode conductor is connected from the panel to a grounding electrode, such as a ground rod or a metal water pipe. The grounding electrode conductor must be sized according to the NEC. In addition to grounding, it's also important to provide overcurrent protection for the branch circuits in both panel A and panel B. Overcurrent protection devices such as circuit breakers and fuses are designed to interrupt the flow of current in the event of an overload or short circuit. Each branch circuit should be protected by an overcurrent protection device that is sized to protect the conductors in that circuit. The size of the overcurrent protection device must be in accordance with the NEC. Let's also touch upon the importance of labeling. All electrical panels should be clearly labeled to indicate the circuits that they serve. The labels should be accurate and up to date. This will help to prevent confusion and make it easier to troubleshoot problems. When panel B is fed through the lugs of panel A, it's especially important to label panel A to indicate that it serves panel B. This will let anyone working on the electrical system that panel is supplying power to another panel. The labels should be durable and weather resistant. They should also be easy to read. Using a label maker is a good way to create professional looking labels. In addition to labeling the panels, it's also important to label the branch circuits. Each branch circuit should be labeled to indicate the load that it serves. For example, a branch circuit that serves a lighting fixture should be labeled lighting. A branch circuit that serves a receptacle should be labeled receptacle. Let's also discuss the importance of regular maintenance. Electrical panels should be inspected regularly to ensure that they are in good condition. The inspection should include checking for loose connections, damaged wires, and corroded components. Any problems that are found should be corrected promptly. Electrical panels should also be cleaned regularly to remove dust and debris. Dust and debris can accumulate inside the panel and cause overheating. It's important to use a vacuum cleaner or a soft brush to clean the panel. Never use water or other liquids to clean an electrical panel. In conclusion, when panel B is fed through the lugs of panel A, it's crucial to include the load from panel B in the load calculation for panel A. Failing to do so can result in an overload condition, which can damage the equipment and create a safety hazard. It's also important to follow the NEC guidelines for load calculations, wiring, grounding, and overcurrent protection. Regular maintenance and proper labeling are also essential for ensuring the safe and reliable operation of the electrical system. Remember to consult with a qualified electrician if you have any questions or concerns about electrical installations. Electrical work can be dangerous, and it's always best to leave it to the professionals. They have the knowledge and experience to ensure that the work is done safely and correctly. Additionally, let's explore some common mistakes to avoid. One common mistake is failing to account for future expansion. When calculating the load on an electrical panel, it's important to consider any potential future additions to the electrical system. If you anticipate adding more loads in the future, you should factor that into your calculations. Another common mistake is using incorrect demand factors. It's important to use the correct demand factors for the type of load being served. Using incorrect demand factors can lead to an inaccurate load calculation. Another mistake is using undersized conductors. The conductors that supply power to an electrical panel must be sized to carry the total load in the panel. Using undersized conductors can cause overheating and voltage drop. Voltage drop is a reduction in voltage that occurs when current flows through a conductor. Excessive voltage drop can cause equipment to malfunction. Another mistake is making loose connections. Loose connections can cause overheating, arcing, and even fires. All connections should be made using approved connectors and terminals and should be tightened properly. Another mistake is failing to properly ground the electrical system. Grounding provides a path for fault current to flow back to the source, tripping the breaker and preventing electrical shock. The grounding system must be installed in accordance with the NEC. Another mistake is failing to provide overcurrent protection. Overcurrent protection devices, such as circuit breakers and fuses, are designed to interrupt the flow of current in the event of an overload or short circuit. Each branch circuit should be protected by an overcurrent protection device that is sized to protect the conductors in that circuit. Another mistake is failing to label the electrical panel and branch circuits. Clear and accurate labeling is essential for preventing confusion and making it easier to troubleshoot problems. Finally, another common mistake is neglecting regular maintenance. Electrical panels should be inspected regularly to ensure that they are in good condition. Any problems that are found should be corrected promptly. In addition to these common mistakes, it's also important to be aware of the potential hazards of working with electricity. Electricity can be dangerous, and it's important to take precautions to protect yourself from electrical shock. Always turn off the power before working on any electrical equipment. Use insulated tools and wear appropriate personal protective equipment such as rubber gloves and safety glasses. If you are not comfortable working with electricity, it's best to leave it to a qualified electrician. Also, consider the specific requirements for different types of installations. For example, the requirements for an electrical installation in a commercial building are different from the requirements for an electrical installation in a residential building. The NEC provides specific requirements for different types of installations. It's important to be familiar with the applicable requirements before starting any electrical work. Furthermore, remember that electrical codes and regulations can change over time. It's important to stay up to date on the latest codes and regulations to ensure that your electrical work is in compliance. You can obtain information about the latest codes and regulations from your local electrical inspector or from the NEC. By following these guidelines and avoiding these common mistakes, you can help to ensure the safe and reliable operation of your electrical system. Remember to always prioritize safety and consult with a qualified electrician if you have any questions or concerns. Safety should always be the top priority when working with electricity. Take your time, follow the instructions carefully, and don't hesitate to ask for help if you need it. Electricity is a powerful force, and it should be treated with respect.